So this is a voltage divider we already discussed yesterday, and it is the application of the voltage divider. If you look here, guys, so here we can say that how can we have variable output basically. So here we have V out, okay, and by using a variable resistor here, we can get here variable output by using voltage divider circuit. So voltage divider can be set up for variable output using a potentiometer. Okay, this is a called a potentiometer. In a potentiometer, one arm is movable. Yani this arrow which you can see is movable. It can go up and down. So in the circuit shown, the output voltage is variable. How it is very variable? See guys, if you look here, how it is variable. So the output, if I ask you guys, can you tell me what is V out here? The formula for V out? V out. And or we can say what is the V out? V out is VR2, any voltage across R2. So we know the formula, voltage divider formula. Yesterday we discussed what it was, R2 over sum of the resistances R1 plus R2 and multiply by Vs. Clear? So the thing is, here we can see that the R, this resistance is basically variable. So this output is directly depending upon R2. So if R2 vary, the output will also vary. So look here the situation. When we vary this resistance and bring this R here down. Okay. Are you getting this? When it is down. So can you check me at that time, how much is the resistance from this ground to here, up to here? How much is the resistance?
0.
Exactly, it is 0 because of the it is short circuit now, and the resistance between this point to this ground, this is called ground, okay? Between that point, basically, it is 0. So when it is 0, can you just think here, when we put the value of R to 0 here, what we will be getting here from this formula? Will it be 0? Because R2 is 0. Okay, so we will be getting 0 volt at that time. Now think another situation. In another situation, basically, we are saying like when the this arm, yani this arrow is at the top, this place, because it's movable. As I said, it can go up and down. When it's reached to that maximum point, okay. So if I ask you guys from this point to ground, how much is the resistance?
10.
Exactly, this is 10 volt. Okay, so when you put this value here, 10 over 20 plus 10 yani 30 multiply by 15. So it will be 150 over 30, that is 50 volts. Are you getting? So the thing is that by having this variable, this one, so output is variable now. So this V out is variable. By moving this, by changing the value of this resistance, we can have a variable output. So if I ask you guys, what is the maximum output which is available from this, available here? What is the largest output voltage available? So we have seen that the largest voltage which is available is how much? 50. And if I ask you what is the minimum voltage which is available, you will say 0 volts. Is this clear to all of you? Okay, let's move to next now. Look here this question, guys. Use the voltage divider rule to find V1 and V2. Then find the power in R1 and R2 and then PT, total power. So tell me now, how can we find voltage divider rule? Find V1 and V2. So it's so simple. First you need to find V1. What is the formula for V1? V1 is equal to R1 over R1 plus R2 multiplied by Vs. Okay, yeah, exactly, yes, correct, Ali. So here then we have to write 470. Quickly calculate, guys, please. 470 over 470 plus 330 multiplied by 20. I need the answer here. So how much it will be? 470 over the sum 800 multiplied by 20. So how much is the value? How much is the V1? Okay. Uh, if you will not respond, I will leave here. See, it's your choice. Okay, this is the way to get it. Then similarly, same way you can get the V2. V2 you can get it Vs minus V1. Then you will be getting V2. It's your choice. If you wanna interact, you can interact. If no, then I will solve it and I will like move next. Then this is a way to get the V2 by using this formula. Then they are asking the powers. So you can calculate the powers. P is equal to, we know the formula to calculate the power. P is equal to V into I. Either we can use it or we can use V square into R. So we can say P1 is equal to V square into R1, V1 square like that. So V square we already calculated whatever. Okay, Ali, if it is like 11.75, then it is a square. You have to put it here, then R1 and 470. You will be getting the power. Okay. The another one, okay, the same way then you can get if, okay, if it is 8.25 volts. So then similarly, you can get P2. Calculate the power also, Ali. P2 will be same way V2 square into R2. So V2 square is 8.25 square into R2 and R2 is 330 ohm. This way you can get these two parts, P1 and P2. Now finally they are asking calculate the PT, total power. Okay, so there are two ways to calculate the PT. Either you calculate the PT is equal to Vs square into RT. So RT any total resistance, right? This is the one way. Or you can also calculate PT is equal to P1 plus P2. Both are okay. Both ways you can calculate. Is this clear?
Yes.
Okay. Why you said Ahmed no? If you not understand, you should ask what is the problem. I explain every step. What is the problem? Where is you did not understand? Speak. You have mic to speak. What is the problem? So what is the problem? You should ask. What is the problem? What is the last step? What is that? See, total power. Total power, two formulas, either you can use this one or this one. This is the power formula, same which we used down. So total power, when you are calculating, you need a total voltage and you need a total resistance. Use it this one, or you can add these two powers, P1 plus P2. Then you can get it, the total power. Okay. So look here now in this question. So this is the last question, guys, and you can see here we have multiple batteries here. Can you see this? We have more than one batteries now. So for the multiple batteries, how we will be doing dealing with this? So last time I explained to you, if you have multiple batteries, so how can we interact with the multiple batteries? So let's see now.
We add them together.
Yeah, we need to consider them algebraically, right?
Yeah.
So this is something which we need to take care of it. So this is a good question to understand that concept. So we have given the direction of current flow, which is clockwise, and then they are asking here to calculate the current I in the given circuit. So I they are asking basically, right? So see this one, you can apply the loop equations, the general equation. What is that? Algebraic sum of all the voltage is equal to 0. We can apply the loop equation. And if you remember that, I told you, you just need to consider the first sign. So from any point you can start. For example, I want to start from here. So I will start this journey. Then I will be going up direction, then completing according to that one. So what is the first sign here of this drop of this voltage? Negative. Okay.
Yeah.
So I will be writing 12. Then what is the first sign? Plus. Okay. And how much is the drop here? Can you tell me?
10 ohm.
No, 10 ohm is not the drop. 10 ohm is the resistance. I want to know the drop. What it will be? It is basically V1. Okay. It is given, for example, it is given V1, right? We'll see what is the V1 later on. Now next, how much is the drop here? And what is the sign? Plus
V2.
V2. Then here
6
Minus
volt.
6.
minus 6. And here
V3.
plus V3. Then
Plus
here
V4.
plus V4. And then finally, all it is equal to
0.
Okay. This is what basically what we called KVL, Kirchhoff voltage law equation, right? Now, guys, we need to find this V1, V2, V3 and all. How can we find this V1? So this V1 is basically not given. What we have given? We have given the resistance only, right? 10 ohm. If we multiply this 10 ohm by this current, will it be the value or not of V1? Yani, can I write V1 is equal to 10I? It is possible? Ohm's law, V is equal to IR. Are you getting?
Yeah.
So write these values now accordingly and look first what is here. Minus 12, minus 6. How much it is?
Minus 18.
Minus 18. So can we bring this minus value other side of the equal?
Yeah. We put 18, then equal V1, V2, V3,
Okay, like
V4.
that. Okay, 18. Now write the value of V1. What is the value of V1? 10
Oh,
I.
I.
Okay. Similarly, what is the value of V2?
20,
What 20?
20 I.
20 I. Okay.
40,
Then what is the value of V3?
40 I.
40 ohm. It could V can be ohm.
No.
What you should say? 40
I.
I. Yeah, you need to apply Ohm's law, na? Similarly, V4,
20
what 20?
I.
20
Let's
I. Understand or not? Because we are applying here V is equal to IR, Ohm's law, to calculate all the voltages. I is unknown. Now, can you add all these here?
Yeah.
Because all are I can be taken common, right? So when you solve it, 10 plus 20 plus 40, 30 plus 40, 70, 70 plus 20, 90. Will it be 90I or not?
Could be.
Okay. Now you can calculate I. I will be 18
19
over
over 90.
90. Okay. Now how much it will be?
0.2.
1 over 20 and 2 over 2 is 0.2.
1
Okay.
over 5, or I is equal to 0.2 amperes. Is this clear to all of you?
Yeah.
So this is the way. So, and this method, KVL, Kirchhoff voltage law, it's so important. Okay, so I explained to you the way how you are writing. First, you write the equations, Kirchhoff voltage law equation. We go through according to the given direction. We write the equation. Then we put the values of all the voltages by applying Ohm's law, I into R. Then we simplify this equation and we can get the value of this current, because they ask here calculate the current. All right, guys, clear to all? Any question, any doubt? Clear, right?
Yeah, it's clear, doctor.
Okay. So these are the questions, guys, which is mentioned at the top. You can see 7A, 10, 13, 19. These are the book questions. These are recommended that you should open the book and solve these questions for the good practice.